the phenol, and para nitrophenol. We know the nitro group shows minus R, it also shows minus I. Both these factors will make what? This benzene ring electron deficient, oxygen will be donating electron much easily. So what we find is this is more acidic. Whereas on the other hand, if we have what? A methyl group at the para position, this is what showing plus I. So what we find is phenol is more acidic. So this is how we can easily compare the acidic natures of the different types of phenol. Let us see one more reaction which is involving the cleavage of the OH bond of the alcohols and the phenol. And the best example for this one we can take is the esterification reaction. See, esterification is the method of preparing esters from when the acids and the alcohols are reacted in presence of an acid. So we know the basic that if we are having any acid and it is reacted with an alcohol in presence of an acid, mainly we take sulfuric acid. What can happen is the H can move out, H moves out from the alcohol and the OH from the acid, they goes out, and what we get in this is RCOO R dash plus water. See, this reaction is reversible because the ester can react with the water in presence of a sulfuric acid to form the acid and the alcohols back. Therefore, as soon as the ester is formed, it is to be distilled out immediately so that the reaction's reversibility is avoided. We can take the example of taking acetic acid and methanol, which is done in presence of sulfuric acid. What we get is methyl acetate plus water. The same esterification can also be done in place of taking acids. We can take anhydrides also. Like, let me give you an example of this one. We can take alcohol or phenol. Yes, like if we are having phenol and we have taken, this is called acetic anhydride in presence of acid, what happens is we will get CH3COO C6H5, we call it phenyl acetate plus sulfuric acid. So the same thing can be done with this, but again this reaction is also reversible because ester with acids and in presence of the carboxylic acid, in presence of the sulfuric acid or stronger acids, can again give back us the anhydrides and the alcohol. So this is again is a very nice example, but the reaction is reversible. But what we can do is we can prepare esters yes, without involving any reversibility of the reaction by taking acyl chlorides. That reaction is not reversible and the reaction is carried out in a basic medium. If suppose we are having RCOCl, these are called acyl chlorides. When they are taken with any alcohol in presence of bases, base like we have pyridine, what we get is the H and the Cl moves out. So what we get is RCOO dash plus HCl. This reaction is not reversible. So it's one of the best methods of preparing the esters. Like we can have COCl, this is called acetyl chloride, and we have taken suppose ethanol in pyridine, it forms CH3 C double bond double O CH2 CH3 plus HCl. So what we get is called ethyl acetate. So this is what the esterification reaction is. The same reaction, this esterification, is also used to prepare aspirin. Now let us see the preparation of aspirin from salicylic acid. See, this is the salicylic acid is 2-hydroxybenzoic acid. Now, if we react this with acetic anhydride, or if we take any acyl chloride in presence of the acidic medium, this acid group, acid derivative will react with the OH group, not with the acid group, and what we get is OCOCH3 COOH plus CH3COOH. This is called 2-acetoxy. It's called 2-acetoxy benzoic acid, or we also call this one as aspirin, which is a very common analgesic and antipyretic. So this is how we can prepare aspirin. Let us see now the reactions involving the cleavage of the CO bond. So it will be involving mainly the reactions of the OH group. Then the first in the category are the reactions with halogen acids. We know we have done in the preparation of the alkyl halides, like the alcohols with HCl in presence of ZnCl2, yes, gives us alkyl chlorides and water. We know the same alcohols with HBr in presence of H2SO4 and reflux gives us RBr and water, and the alcohols with HI in presence of what, H3PO4 and reflux gives us alkyl iodides plus water. So we know the details of these reactions we have already done in the preparation of what, the alkyl halides. The second category of the reactions which involve the cleavage of the OH are the reactions with PCl5, PCl3, SOCl2, PBr3, PI3. We know alcohols with PCl5 definitely gives us what, alkyl chlorides plus POCl3 plus HCl. This we have already done again in the preparation of alkyl halides, so these are just the repetitions. PCl3 with alcohols with PCl3 gives us what, RCl, alkyl chlorides plus phosphorus acid, and the alcohols, all type of alcohols with thionyl chloride SOCl2 gives us what, RCl plus SO2 and HCl, and we prefer to have this reaction because both these products, SO2 and HCl byproducts, are gaseous in nature. We can also get alkyl bromides by taking either PBr3, or we can take red phosphorus and bromine, and what we get is RBr plus H3PO3, or we can take alcohol and we can react this with red phosphorus plus iodine. It will give us Ri plus H3PO3. So this is how we can have chlorides, bromides and iodides from alcohols very easily. The third category of reaction involving the cleavage of the CO bond is the reaction involving dehydration. So we write it as dehydration reaction. See, alcohols, like I can give you the example of, let us take example of ethanol. When reacted with sulfuric acid or phosphoric acid at around 170 or above degrees Celsius, they lead to the formation of what, alkene. So ethene is formed along with water. The isopropyl alcohol we can have this one. This on reaction with 85% phosphoric acid at 167 degrees Celsius gives us what? Propene. Whereas tert butyl alcohol with only 20% phosphoric acid and at around 85 degrees Celsius gives us what? An alkene. Now this shows that these reactions shows that the alcohols in strong protic acids, or the alcohols with strong protic acids and on heating or in the presence of alumina or aluminium zinc chloride like kind of dehydrating agents easily forms alkenes. Like this one, these alkenes are being formed. Let us see the mechanism of one of the formation of these alkenes, and we can take the example of the ethanol. What happens is, let us see the mechanism. The sulfuric acid breaks down into what? H plus and HSO4 minus. Then in the second step, what happens is that on this alcohol, this H plus attacks on this oxygen, giving you what? CH3, CH2, OH2 plus. Now this oxonium ion formed like this one. This moves out because water is a very good leaving group. Therefore from beta carbon the hydrogen is H plus is removed out. So what we get is CH2 double bond CH2 plus water plus H plus, and this is how the ethene is formed. So this is what is the mechanism we have, which is the dehydration of alcohols.